finished in time, but the people that were truly, I think actually the more you know, the longer it took. So I think this class is going to probably need a little longer because typically you do pretty well on those. So. All right, so on the first page, we're starting a new lesson, but it's got a lot of the same stuff we did. So it's still on writing proofs, but now we're specifically writing proofs that are related to line segments. We've already done line segments. Like we did midpoint, we did, what was the other thing we did in line segments?
Changed.
Well, not naming like line segments, like when we did, what's that? Midpoints, I said, say it again. Little plus little is big is a big one. We're gonna have to use the more official name for that when we do proof. You can't write little plus little is big. You're normally going to be choosing from the list anyway, so you got to know the name of all of these things, the official property or theorem or whatever definition. But we've done a lot of this stuff already. So. All right. So we didn't really call this the rule or postulate, but we did it before. I'll just kind of write over here what we did. So we had a line segment. We had a line segment. I said, well, if that line segment has endpoints of 3 and 10, how long is that line segment? Right? That's really all the rule or postulate is. It says that the numbers of a line segment, the endpoints or points on the line segment, correspond with like an imaginary number line. So you can think of this as a number line that goes on forever in both ways. It just happens to, we're starting at the number 3 on the number line and going to the number 10 on the number line. That's all the rule or postulate says. But you can figure out the length by using the numbers that make up the line segment. I don't know that I've ever seen that in a proof. It might have been in one, but it's probably not one of the more important ones. When I tell you something is important, which I've already done with a few of them, those are the ones you need to key in on, certainly for my quiz. And I think they're going to be probably, certainly some of them will be on the district and EOC stuff. So that's really it for that one. So here's the next one, segment addition postulate. These are in your book, so you can look in your book and look up here. It tells us that if we have 3 points that are collinear, we know point B is between, so they drew a little picture for you. Then it's saying that we can say AB, or is it AB plus BC equals AC? What is that? That's little plus little big. But we've done that. That's not new. You just now are going to have to call it when you write up the reason, or eventually when you choose a reason from a drop down, you're going to make sure you call it these. And there's a few different names. IXL uses a different name, very similar, but not exactly the same. So there's segment addition postulate, could say line segment addition, could say, what's the other one? The addition property of line segment. So it kind of flips the order, but you're still looking for line segment or segment and then addition in there somehow. And then obviously make sure that it makes sense with what's going on, that it's little plus little is big. So if you want to write a note next to that, that's just little plus little is big. So nothing super new there. We don't get to this one today, but again, midpoint is a big one. So that's a big one, right? So make sure that's one you emphasize, that you understand. Like, you should know that one, be able to recite that one in your sleep. Like, that's just little plus little big. I know if I see a point between 2 other points now, don't get it confused with midpoint, because you're going to see some that are the midpoint too, and they may put something like this in there, but one of the options may say midpoint, and they may even draw the point close to the middle. If you don't have information telling you it's the midpoint, you can't use midpoint. It would be this one more or less. Information that would tell you it's the midpoint is if they tell you the 2 segments are equal somehow, like either in the given information or with congruence marks. or they might just say point B is the midpoint. Then you would go to like the definition of midpoint or midpoint theorem, and what's the only thing that really, like, what's the only statement we can really make from something being the midpoint? Yeah, we can say that. Now we could still make this statement. I shouldn't say that's the only statement. We could still say this also, but more likely, if they're telling you specifically it's the midpoint, it's because they're going to want you to somehow state that the two segments are equal at some time during the proof. So midpoint, we did substitution. That was a big one. Make sure you put a bunch of stars next to substitution. We'll see that one again today. I would say almost like every other proof. So 1 out of every 2 proofs probably are going to have substitution in it. We did definition of congruence. You're going to see that one in a second when you do this practice. So all of those are the most important ones that we've talked about so far. We'll see some more before the quiz on Monday. Oh, your quiz is on Monday, by the way, if I didn't already say that. Let's see. So I think that's it for that page. Now we're just going to do a proof, and then we're going to go do the quiz. So I want you to try to do this one on your own. I don't expect you to be able to do the entire thing. I would expect you to be able to get the second statement, and I would expect you to be able to get the third reason. The fourth line is tough, and the sixth line is really tough. I don't expect anybody to get the sixth line. But I'm going to go over all of them. Sometimes learning proofs is just a matter of reading through a bunch of proofs that are already completed to just remember some of the concepts that you might have forgotten, plus to just learn how to follow the logic on just how to write a statement in a reading. I'm as far as that last thing we did, those postulate numbers and then any postulate numbers. No, they'll never have just postulate, because first of all, I think those numbers were just for that particular lesson. I don't think that's like an official. I don't have any staples in this paper, so we said we'll do it later. Oh, unless there's some in that one, yeah. The one up here is out. So I'll give you like 5 minutes to do that. I want to get in the lab with about an hour. The other classes didn't have quite that long, but it'll take you guys probably a minute to log in for the first group today. Some of the computers don't work, so I put X's on the ones where people have trouble, so don't choose those. Like X's on the cardboard thing on the computer. I'm going to do attendance. Oh, I can't do attendance. I'll wait. Oh, I didn't see those. Wait, is that one way over there?
There's a tiny one.
This one way over here? That's not one of them. Yeah, well, that's just from sharing pages now. I was gonna say, how did somebody throw that one? So I'll give you a couple more minutes. We're just gonna go over it anyway. So if you can get all the way through it, you can keep working. But like I said, number 4 is pretty hard. Number 6 is virtually impossible. I wouldn't have even come up with number 6. I've not even ever heard of it. I would have just skipped over line 6 kind of. Again, the district test, the other classes had about 40 to 45 minutes. I'm going to give you guys probably a little bit longer than that. I think some people in here will work on it a lot harder than some people in the other classes. I mean, a few people in the other classes. The highest grade so far is only a 60. So I expect this class to do better than that. And so there'll be 1, 2, and 3 pride books depending on your score. I think it looks like a 50 to like a 60 will probably be 1. It looks like a 60 to a 70 will probably be 2. Actually, 60 to like 50 to 65 will be 1 probably. 65 to 80 will be 2, and then if you get over an 80, you'll get 3.
What's the highest thing? Like percent?
So far on this one, it's 60. Second period kind of got second period kind of got gypped because I didn't bring in reference sheets. Yeah. Normally the reference sheets are in the program. Like you click on tools and there's a reference sheet. It wasn't in there though, and I didn't have any.
Stayed in
So they didn't have a reference sheet, so their scores were a lot lower than others, so they kind of got. Yeah, we're gonna take our stuff and everything. So I'll bring reference sheets, so you guys have a little bit, although the other classes after second period had reference.
Yeah.
No way.
I have second lunch and I have to be.
Well, but you gotta, it's open on the days that they have the Friday.
Last Friday, it's. Last Friday, they didn't even open it.
No, yeah, they first like I literally walked in.
Well, that was the day, the last day of the quarter. Yeah, I said you were gonna use your, they didn't even have it open.
No, they didn't even open it for anything.
Well, they didn't announce it was gonna be open like on email.
Yeah.
I'll ask if they're gonna extend the date, so don't throw any of them away yet. Somebody said they thought they were good till the 20th anyway. One of my other classes said that. So don't throw them away if you have a bunch.
I only have.
And if it wasn't open, maybe they'll extend it. I'll ask, at some point, I'm planning next week. Oops.
Yo, that's my cat.
No, that's fine, that's fine.
$8.
All right, let's go ahead and get through this real quick so that we can get over there. Yeah, just 4 is always hard just because you got to come up with the statement and the reason. That always makes it a little tougher, but I'll show you a little trick. So when we start the proof, what's the first thing we're probably going to use? So this is kind of like, if this is a gift, if you ever have blank lines on the first line. Given information. So the only given information is this. So that's what we started with. And then the reason will always be given. So that is like you ever have a blank on the reason and the information that's written here is right in the given, that's just a given. So they already filled that out. So in this one you didn't have a super easy one. But I have seen some of those where they have a blank. Is it? Oh yeah. They have a blank in the reasons, and the reason is just given. So they do give you that sometimes. So don't forget about that easy one. Next. So here's what we're trying to figure out. We're trying to figure out what would I do? And it doesn't always flow. The line above doesn't always flow directly in the next line. Sometimes they kind of move to a different piece of information, especially if there's more than one given thing, or if there's a picture. Sometimes this is like given information also. You can state R is between Q and T because of the picture, even though they don't tell you R is between them. So the picture is like given information. You take that as true. You can use that when you do statements and reasons. What did I say definition of congruence was? That's another easy one. Better highlight that one, especially if you didn't know it. It only does one thing. Yeah, you are making the exact same statement, except you're changing it. I'm not going to do the lines over it, but there should be lines over it. You're changing the symbol from congruence to equals, or it could be the other way around. It could go from equals to congruence also. So this is a congruence symbol. We said that means that the shapes are the same. One shape would fit right on top of the other. The equal sign means they have the same length. We're going to be talking about numbers if we're using the equal sign. But it's an easy one. If you look at it, you're like, well, that's the same exact thing. Or if it tells you definition of congruence here, which it does, then you better get those right. Not a difficult one. You just got to memorize it. The real concept you have to understand for that one to figure it out. Now it starts to get a little tougher. We're not really going from 2 to 3 in this one. So they're related. 3 is really more using the picture than anything else. So this is a situation where, again, trying to go from here to here. I mean, there's still elements of it. We see QT here, and then QT is down there. We see RV there, and then RV is there. But really they're more making this third statement based on the picture given. What is that reason? Does anybody think well, raise your hand if you think, yeah, I got it. I know what that reason is. That was, when I say it, you'll be like, oh, yeah. But to come up with this stuff on your own, that's why I say you just got to practice. I'll print the answer sheets out, by the way, like I've been doing and have them available for Friday. All right, so what do you think it is?
Addition, property, and equality.
Yeah, it's the one we just learned. First of all, the examples tend to use whatever we just learned. So that's little plus little is big. We just,
I wasn't sure.
and segment addition is a fine way to say I'm fine with that, yeah. So you could say segment addition, you could say addition property of line segments. Again, it's the same thing depending on which book or resource you use. Addition of line segments, property would be in there somewhere, but as long as you got addition and line segments, you're pretty good. Say it again. Well, you got to name the right one, but that's what you're doing. Like you're coming up with, why can I make that? Like, this is the statement I'm making, and then you have to say, why am I allowed to say that? Well, I'm allowed to say that because I have a picture that shows R is between Q and T. Well, if R is between Q and T, then we learned that QR plus RT has to equal the whole line segment, the QT. We make the same statement here because we see in the picture that T is between RV. Well, if T is between those two, then from R to T plus T to V has to equal the whole line segment. Again, it's little plus little is big. Just we're using the more formal name. So that's what allows us to make this statement. This property allows us to make those two statements. That's what a proof is. You're making a statement, and then you're saying why, like what definition, what theorem, what true fact about math allows you to make that statement. Now I get a little tricky. We got to somehow come up with what would be in between these two. What would I go to from here to here that would then allow me to go from here to here? And I don't have a reason to help me out with it. I'm going to also have to come up with that. So here's a strategy. Make a note on this. Sometimes it's easier to see what would have to be before this. So instead of trying to figure out what do I go to, or what do I go to, from here, think about, well, what would I have to have up here to get this? Sometimes that's easier. And I think in this case, it is easier to do that. So let's look at 5 first. In 5, they tell us what it is. We got all the information. We got the statement and the reason. And it says, I'm doing the subtraction property of equality, which we haven't ever done before, not as a formal name, but you've done it all the time. You've done this since 7th grade, probably, maybe 6th grade for some of you. This is a totally separate thing. Don't get confused. I'm giving you a different example to show you what this is. So let's say we have an equation. 2x plus 1 is 7. We want to solve for x. What's the first thing you do? You subtract 1, right? But if we subtract 1 there, what do we have to do? That's the subtraction property of equality. It says if you, and there's other ones, addition property of equality, multiplication property of equality. I don't know if they call it the quotient property or the division property of equality. This is whatever you do to one side, you got to do to the other side. That's what that is. So it's just telling you if you subtract on one side of an equation, you have to subtract on the other side. Now, again, it may not be super obvious that you know that that's happening, but where are we subtracting in there in that 5, statement 5? What are we subtracting? RT. Right, we're subtracting RT on both sides, right? Whatever I do to one side, I have to do to the other side. That's the step we are taking in that, is to subtract RT from both sides. That's what it says we're doing. It says we are doing subtraction to both sides. So this is the step we're doing on statement 5. So now, figure out statement 4. Try to write it down. That's your hint if you didn't. And again, I would not have expected you to get that on your own before. Now I expect somebody to get it. So you're kind of going backwards and figuring out, well, what would have to be in 4 if this is the step that I'm making here to subtract the RT and subtract the RT. If you're still not getting it, don't worry, proofs are difficult. That's why you just got to do a bunch of them and you got to read. I'll give you some that are already worked out. Like I've got some I'll print up. When you do the practice ones, I'll give you the answers so you can kind of see the proofs. But the more of them you do, the more you'll start to see the same reasons pop up, and the better you'll get. But they're tough when you first start them for sure. All right, so raise your hand if you think, okay, now I understand what goes there. I think I know what this is. Still no. So what did I do in step 5?
Subtracted RT.
From both sides, right?
Yes.
So what would have to be above that if I'm going to be subtracting RT from both sides? No, I'm doing this step here
To make it into an equation.
to get, well, don't worry about why I'm doing it yet. We're just trying to figure out what goes there. If I'm doing this step, I would have to have something up here that comes from. Oh. What? Tell me what. Yeah, that's all I'm doing. In order to subtract this from both sides, I have to have this up top. I have to have this, and I have to have this. That's what goes up top. Because then from that, I'm going to subtract RT on both sides. I'll tell you that in a second. First, let's write that. So write that in. So again, if I know this is what I'm subtracting, well, I had to have the other stuff up in the other line in order to then subtract from that. So that's why I say sometimes working from bottom to top, or at least from bottom to the step above it, helps you figure out statements easier than working from top down. Now I want you to see, again, the reason's still kind of tricky, but if you look at the line above it, that's what would tell you the next, or not the next, but the reason for number 4. You got to look at the line above it and see if you can figure out. I'll give you a hint. It's one of the big ones. One of the ones I said you better know. Give you like 30 seconds. If you don't know, I guess I want you to get the shots. I think we got through more of this in one of the other classes. I can't remember. Yes. All right, so again, now raise your hand if you think, and again, I would not be surprised if none of you are still seeing, but raise your hand if you think you see what's happened to go from this to this. Anybody? Maybe? All right. What did we, so here's where sometimes you got to look at a couple lines in a row. So look at this kind of combined with all of this, both of those. They went from saying, okay, well, we know QT equals RV. Then they explained what else QT equals. What we basically did is we said, okay, let me just get rid of that. Okay, it's getting a little slow. So I know, oh, I didn't mean to erase this. I know that QT equals RV, right? But I also know that QT equals all of this. So what they've done is they said, okay, well, if I know this also equals this, right? Because that's what it says right there. QT equals that. I'm just going to replace the QT with that statement that it equals. And I put it right there. What's that? Substitution. So they're doing something. And then they did the same thing with RV. I know RV equals all of this. Well, then I'll replace that R of E with all of that. So I told you substitution's a big one. One hint for substitution. If you got a lot of equal signs. Oh, I can't highlight this. I guess I'll do it live. If you got a lot of equal signs in a problem, and you made that, assuming you got to that statement, there's a good chance substitution's involved. Because a whole bunch of things are equal to each other, which means you can like move them around. So a lot of equal signs in a problem, in a proof, means that you might be using substitution at some point. Make that note too. Absolutely not. Money means nothing to you. That's not worth telling you what the question was. I think it was a joke. So I don't know what happened down here. So that was substitution. I didn't write it all the way out. Oh, I don't know what I did. It's zoomed somehow. It zoomed in. I don't even know how to do that if I want to do it. So I don't know how. Every once in a while I do it accidentally. So where? Oh, over here. Did I click it over here or somewhere? No, that just. Oh, up there. I must have clicked on that. So that's substitution. So this last one, I'm not even worried about you really knowing this one. This one's like called the substitution property of equality. You're really just doing the math. I've never even heard of this one. So just write it in, property of equality. I would have just said you're doing the math. You're just subtracting RT from both sides, and that gives you QR equals TV. So apparently when you just are doing the math, that's called the substitution property of equalities. And then we go from that to that, right? Nothing else changes. So we use that again. Definition of congruence can go from congruence to equals or from equals to congruence. So I think I did the check in second period, but I want you guys to get in the lab, so I'm not going to worry about doing the check. You can try to do the check on your own, because we'll go through it on Friday. It's right below that, yeah. All right, so here's what you need. When you get into the lab, everybody focus. I don't want to have to keep repeating it. When you get into the lab, you will log in using the 00040. You will need a pencil and some scratch paper. I will pass out calculators. And I'll pass out a reference sheet.
And you provide scratch paper.
And you're going into performance math. You can have it, but you can't have a notebook out. You're going to tear a couple pages out.
Can you like provide scratch paper?